Today we will be studying perpendicular and parallel lines. In our daily life, we see around us a large number of examples which have both perpendicular and parallel lines. A table. The legs of the table and the tabletop are perpendicular to each other. The tabletop has sides which are parallel to each other. The adjacent sides of the top of the table are perpendicular to each other, while the opposite sides of the tabletop are parallel to each other. The sides of the laptop and the sides of the mobile phone, again, the adjacent sides are perpendicular and the opposite sides are parallel. Let me show you a tray here. Now in this tray, I have these two sides as opposite sides. Similarly, these two sides are opposite sides. The opposite sides of the tray are parallel to each other. Each corner angle is 90 degrees. So the adjacent sides of the tray are perpendicular to each other. Perpendiculars are two lines forming an angle of 90 degrees. Then the two lines are said to be perpendicular to each other. The symbol for perpendicular is this. I have drawn two lines PQ and RS. The angle between PQ and RS is 90 degrees. This is how the angle of 90 degrees is represented. And I write PQ is perpendicular to RS. PQ and RS are intersecting lines, so I say that they are perpendicular to each other at O. Now since angle POS is 90 degrees, all the other angles also will be 90 degrees. Here I have drawn a line XY. Line segment MN is perpendicular to XY, and we can also say that line XY is perpendicular to MN. Now here I have drawn a line segment GH, and the ray FE is perpendicular to the line segment GH. The perpendicular distance between any two lines is the shortest distance. Now to draw perpendiculars, we can make use of what we have in our geometry box, a set square. Here I am showing you a set square from the geometry box. It's like a scalene triangle and it is right angled. Now this angle is right angle or 90 degrees, so it can measure a right angle. Similarly, this set square is an isosceles triangle with two angles equal to 45 degrees and one angle as 90 degrees. So this set square can measure an angle of 90 degrees, and I can also measure lengths of lines with the help of the set square. Carpenters usually use an L-shaped scale to draw a 90 degrees angle. Next we come to parallel lines. Two lines in a plane which never meet when produced infinitely in both the directions are said to be parallel to each other. Now the symbol for parallel lines is this, and we write, if I have drawn AB and CD, they are parallel to each other, so I have written AB is parallel to CD, and I have drawn an arrowhead in the same direction on both the lines, which indicates that AB and CD are parallel to each other. The perpendicular distance between parallel lines is always the same. We can use set squares to draw the perpendicular lines between the parallel lines. Now let's place the set square in such a way that one of the sides of the set square is along CD, and this angle will be 90 degrees because here the set square is making an angle of 90 degrees. I now just shift the set square slightly ahead, and again along CD is one side, and I draw a perpendicular, and I draw another perpendicular when I move the set square along CD, and now I have three perpendiculars here. The size of the perpendicular is the same as you can see from the divisions on the set square. In the same way, I can also place the set square on this line so that one of the sides of the set square is along CD. So this will be 90 degrees. This is the length of the perpendicular. Now I move the set square along CD. Again, this is 90 degrees and the perpendicular distance is this much. It is the same. So again move it along CD and we'll find the perpendicular distance to be the same. In a similar fashion, I can again place the set square here along CD. Now I draw the perpendicular. I move this set square along CD and I draw another perpendicular. Now just see the lengths of all these perpendiculars as I can measure it from the set square is the same. With the help of the set square, we have just drawn the perpendicular distances for the three pairs of parallel lines. So, and we conclude that the perpendicular distance when two lines are parallel to each other always remains the same. Transversal is a line intersecting two or more parallel lines at two or more distinct points. Now here we have drawn two lines MN and PQ. MN is parallel to PQ. MN and PQ are parallel to each other. RS is a line segment which is cutting MN and PQ at T and U, two distinct points. We call RS as the transversal. The transversals can be drawn for non-parallel lines also. I have shown that also on the blackboard. Here I have XY and ZW which are not parallel to each other, and I have drawn VU which is a transversal cutting XY at T and ZW at R. T and R are the two distinct points at which the transversal is cutting the lines. So a transversal is a line intersecting two or more parallel lines or non-parallel lines at two or more distinct points. If you've enjoyed the video, please like it, share it, and subscribe to the channel. Thank you.